caterpillars are coming from moths. Count the number of moth species in my yard. I am up to 879 species of moths in my yard. There will always be some combination of those species, so that in combination there'll be enough caterpillars to feed those chickadees, regardless of what the weather is doing. So this is an example of diversity creating stability in this food web, or diversity creating stability in the ecosystem. You've heard diversity is good. This is why. It allows these things to breed every year. Okay, a guy by the name of Richard Brewer, way back in 1961, was studying Carolina chickadees, and one of the things he needed to know was how many caterpillars are they bringing back to the nest every day. So he counted a whole bunch of nests, and he found that it was between 390 and 570 caterpillars per day, depending on the number of chicks in the nest. And they're in the nest for 16 days. Now, after they leave the nest, after they fledge, the parents continue to feed them caterpillars for another 23 days, but they're flying all around, so he couldn't count those. So just to the point where they leave the nest, that's 6,000 to 9,000 caterpillars to make a bird that is a third of an ounce. That's 4 pennies worth of bird. What if I wanted to have a red-bellied woodpecker in my yard? It weighs 8 times more than a chickadee. How many caterpillars does that take? And I don't want just chickadees and red-bellied woodpeckers. I want scarlet tanagers and titmice and bluebirds and blue jays, bluebirds, you know, your bluebirds, tree swallows and common yellow throats and indigo bunnings and towhees and yellow warblers and thrushes and house wrens and cardinals and hummingbirds. These are all birds that used to be common in our neighborhoods. And I don't want just one pair. I want breeding populations of them. How many caterpillars does that take? It's a lot. It's a lot. You would say, well, you don't need any insects for Mr. Hummingbird here, because that's actually Mrs. Hummingbird. She eats hummingbird. She eats sugar water. And she does eat sugar water. But 80 to 90% of a hummingbird's diet is insects and spiders, and then they go to get the sugar water. So you can put up your hummingbird feeder, and that's good, but you're not going to make more hummingbirds with that sugar water. It takes protein to do that. And that is true with 96% of the birds in North America, the breeding birds in North America. They are rearing their young directly or indirectly on insect protein. And when I say indirectly, if you eat a spider, that spider became a spider because it ate an insect. So it's all about it's really all about insects as food for birds. And this is news to a lot of people. Most people think about birds eating seeds and berries. Most people who write landscape for birds books will tell you how to put plants in your yard that make seeds and berries, and that's a good idea, because a lot of birds use seeds and berries after they reproduce. But we also have to have the plants in our yard that make the insects that allow the birds to reproduce. Otherwise, you don't have the birds to eat those seeds and berries. So, a bit of a generalization here, but not much. No insects, no baby birds. So how do we do that? What types of landscapes are capable of producing the diversity and abundance of insects that we're talking about here? Well, now we have to go back to specialized relationships, and we have to talk about the most common type of specialized relationship that occurs all over the planet, and that's the relationship between the insects that eat plants and the plants themselves. So the relationship between this polyphemus moth caterpillar and the oak leaf that it's eating. Remember, plants really don't want to be eaten. They want to capture the energy from the sun and use it for their own growth and reproduction. Excuse me, this is my lunch. It was good, but they've loaded their leaves with these nasty tasting chemicals, secondary metabolic compounds that make those leaves either bitter or downright toxic. And it's a really effective defense that keeps most of the insects of the world from eating most of the plants of the world. And that's why in a little bit it'll be green out there. It's not because there are no insects out there that want to eat those plants. It's because most of the insects that are out there cannot eat those plants. They are too well protected chemically. But insects do eat plants, so how do they do that? How do they get around those chemical defenses? Well, this is where the specialization comes in. 90% of the insects that eat plants, insect herbivores, are what we call host plant specialists. They're picking 1 or 2 plant lineages that share a common cocktail of chemical defenses, and they develop the adaptations that are required to circumvent those defenses. They develop the enzymes that store and excrete and detoxify those compounds, behavioral adaptations and life history adaptations that allow them to minimize their exposure to those compounds. But it takes a long period of exposure to those plant lineages for all these adaptations to fall into place. It does not happen overnight. Let's use the monarch butterfly as an example, because you already know half the story of the monarch. You already know it's a specialist on milkweeds. Actually, I gave You ever talked to English 101 up campus at the University of Delaware? I got to this point and said, you already know what they eat. Nobody, including the professor, knew that monarchs ate milkweeds.
That's.
I know. But yes, they are specialists on milkweeds. And you also know that milkweeds are toxic plants. They're filled with cardiac glycosides. That's why we're not out there eating milkweeds. If we ate enough milkweeds, it would stop our heart. That's what cardiac glycosides do. It does not stop the heart of the monarch, and they do have a heart, by the way, because they've got those enzymes that can deal with those cardiac glycosides. They can detoxify them, and they store them in the insect's cuticle and its blood, and then monarchs taste bad. So those are the physiological defenses monarchs have developed to be able to eat a plant that most other insects can't eat. But what about the sticky latex sap? Have you thought about that? The sticky latex sap that give milkweeds its common name. When you break open a milkweed vein, all this white goo comes out. It's not really milk. If you get it on your hand, your finger, usually wipe it off right away, but if you don't wipe it off and let it sit there, it gels. It turns into like chewing gum. And that's the defensive property. If a caterpillar gets that all over its mouth parts, it glues its mouth shut. And then it starves. So you can't have that. Well, we do know that monarchs are going onto milkweed leaves and eating milkweed leaves. So how do they get around that milkweed defense? This is something you can watch in your yard. You plant your milkweeds and the monarchs come. Usually what they do is go to the end of the leaf and they start eating. And if any latex sap starts to come out, they will stop eating immediately, turn around, go back up the leaf, usually maybe 3/4 of the way, 2/3 of the way, and they start to chew through the midrib. And they chew till they have completely severed the midrib. And what they're doing is cutting off the canals that shunt the latex sap from this end of the leaf to this end of the leaf. So now this end of the leaf is entirely latex free. They can turn around, go back down, and then eat the leaf without any latex sap coming out. And that, of course, flags the leaf. So if you're a monarch hunter, you can just drive down the road and look at a milkweed patch and tell whether there are monarchs there, because if you see flagged leaves, there either are or were monarch caterpillars there. Okay, those are the upsides of specialization. By specializing physiologically and behaviorally, the monarch has turned the tails, turn the heads, whatever, turn the advantage around on milkweeds. But those are adaptations that most other insects haven't figured out. So the monarch gets to eat a plant lineage that is unavailable to most other insects. The upsides of specialization. The downsides are that now that's all it can eat. So by specializing exclusively on milkweeds, they haven't spent any evolutionary time developing the adaptations that allow them to get around the tannins that are in oak leaves, or the cucurbitaceans in cucurbits, or the cyanide in cherry, or the nicotine in tobacco. So out of the 2,137 plant genera in North America, they can only eat one, Asclepias. And that works as long as you got Asclepias around. But if you take the milkweeds away, which we have very effectively done, particularly in the Midwest, you lose your monarchs. In 2013, we had only 3.6% of the monarchs left compared to what was here in 1976. And of course, this is a learning event now. We decided we want to keep our monarchs. You know why we want to keep our monarchs? They're pretty. That's a good enough reason. Yeah. So we have Monarch Watch, everybody's planting milkweeds, and it looks like it's starting to work. That's the good news. But remember, there is nothing special about the specialization of monarchs. If monarchs are declining like that because we've taken the milkweeds away, so are everything else that we're not counting. The ugly moths that we don't care about. We have to care about that because that's bluebird food. I don't want you to think that it's just monarchs, just caterpillars that are specialists. This is the elderberry beetle. It only eats elderberry. Dogbane beetle only eats dogbane. Sumac flea beetle only eats sumac. This is a Korean bug, a leaf-footed bug that only eats ash. So if our emerald ash borer succeeds in getting rid of all the ashes, we lose this guy. As a matter of fact, we lose 95 species of ash specialists if we lose our ashes. And that is the problem, the fact that so many of the insects that eat plants are host plant specialists. If you take that host plant away, you lose those insects. There's some good news here, and that is as we learn more and more about what comprises various food webs, we can actually rebuild them wherever we want. All we have to do is put the components back. So let's do that. Let's rebuild the food web of the white-eyed vireo. And I'm choosing that because that is the nest that Cindy found in our yard a few years ago. Now the birds knew that I could not reconstruct their food web if I didn't take pictures of the caterpillars they were bringing back to the nest. If I have a good picture, I can now identify what it is, and then I know what plant made that caterpillar. We know a lot about what caterpillars eat. They knew that, so they built the nest very low, and I could set my camera up. So let's do that for a little bit. This is the blinded sphinx moth. It's a specialist on black cherry. We've got a lot of black cherry at home, making blinded sphinx moths, so the babies get to eat. This little guy is the chestnut schizura, and despite its common name, it's a specialist on native viburnums. Now at our house, that is Viburnum dentatum arrowwood. Excuse me, and I know that because I planted it. Our yard was mowed for hay before we moved in. We know most of the plants are there because we put them there. And our viburnums are now making chestnut schizuras, so the babies get to eat again. This guy with the white stripe is a specialist on sycamore, the drab prominent. We did not plant sycamore, but 2 or 3 years after we moved in, a big wind blew sycamore seeds into our yard. One landed in my cold frame, and it germinated. And I'm not very fast at weeding things out. It's now, it's over 50 feet tall. But it's making drab prominence, so the babies get to eat again. On and on we go. This is the 8-spotted forester moth, a specialist on native grapes. We have lots of those. The lunate zale, another specialist on black cherry. This is the spicebush swallowtail. It's a specialist on spicebush, and its close relative that shares the same chemistry, sassafras. We have both of those. There's the phony eye of the caterpillar there. It's supposed to scare the bird into thinking it's a tree snake. It didn't work.
Yeah, it didn't.
This guy's the tufted bird dropping moth, another specialist on black cherry.
It looks like
So black cherry is emerging as a really important component of this bird's food web. These guys are hungry. They need a lot more than that, so let's put some black walnut in the landscape. We do that, we get the walnut sphinx, the gray edge boma loca, the black blotch caesura, the bride, all specialists on black walnut where I come from. Native maples give us Plagodes inchworms, green striped maple worm, maple bantam dagger moth, and again, many others. This is the American elm. It gives us four-horned sphinx, double-toothed prominent, interrupted dagger moth. Remember, 90% of the insects that are going to be essential for the vireos to reproduce successfully in my yard won't be there if you don't have the plants that make those insects. So if you want the mustard sallow, you need witch hazel. If you want the hackberry emperor, you need hackberry. If you want Cuculio asteroides, you need native asters. The Arcigera flower moth and brown-hooded owlet need goldenrod. The hog sphinx, Pandora sphinx, abbot sphinx all need Virginia creeper. Redbud leaf roller needs redbud. The gray furcula needs native willows. Turbulent phosphilla needs greenbrier. And the orange tufted oneida, the spiny oak caterpillar, the two-spotted oak punky, the variable oak leaf caterpillar, the red-humped oakworm, the orange-humped oakworm, the pink-striped oakworm, the delightful dagger moth, the pleasant dagger moth, the lesser oak dagger moth, the greater oak dagger moth, the streaked dagger moth, the afflicted dagger moth, the white blotch heterocampa, the oblique heterocampa, the red-line panapoda, the laugher, and many, many more won't be there if you don't have oaks. Because oaks are the most powerful plant you can put in your yards here and in 84% of the counties in North America.
That's amazing.
You know where I took all those pictures?
Your yard?
You're supposed to say in your backyard.
In your front yard.
Good. No, I took them in my front yard.
You're killing it.
I don't like the term backyard habitat because it implies what we're talking about here is so ugly we have to hide it in the backyard. It can't be part of our culture. It can be. You can put an oak in your front yard. You can get away with it. It also cuts our conservation area in half. I don't know why the front yard is off limits. Why do we need all these insects? When we talk about bird food, they certainly need them. But if you look carefully at terrestrial food webs, you will see insects are essential components of almost every single one. All spiders, for example, eat insects, or they eat other spiders that ate insects.
That is a cute one.
And I know a lot of people don't like spiders, but who does? It's the second most important component of bird food webs. Even though they're not that nutritious, bluebirds eat a lot of spiders, you know that. And they're very important predators out there. We can't afford to lose our spiders. We can't afford to lose our insect predators that are eating the insect herbivores, because these guys also are important components of food webs. If we lost our insects, we would lose our frogs, our toads, all of the amphibians, because they all eat insects. So do our lizards, so do our bats, so do our rodents, believe it or not. We always think of rodents as seed eaters. And they do eat seed when they can't find enough insects. But the reason these guys want insects is that they're really good food. pound for pound, there's twice as much protein in insect meat as there is in beef. And they have organs in their abdomen called fat bodies. They're loaded with lipids, high energy compounds that allow these little guys to grow quickly and reproduce quickly, which if you're a mouse you want to do because there's a lot of things that want to eat you. Same reason larger organisms are eating insects. They're just really good food. The skunk is digging up your yard to get the grubs that are in your yard. Chipmunks eat a lot of insects. What is that? Possums, they eat a lot of insects. Raccoons eat a lot of insects. Even things we don't think of as insectivores eat a lot of insects, like our friend the red fox here. You know, this is the most common, most abundant predator in the world, on all continents except down there, Antarctica. 25% of its diet is insects. Yeah, 25%, a full quarter of its diet. 23% of a black bear's diet is insects. Doesn't matter how big you are, you need insects. And even if you don't eat insects, you need insects. This is sharp-shinned hawk. It's a bird predator. You might think, well, I can get rid of all the insects in my neighborhood and still have sharp-shinned hawks. But think about it. If you get rid of all the insects, you have gotten rid of the birds that this guy eats. So he needs them indirectly. So does a garter snake. He's not eating insects directly. He's eating the frogs and toads that ate the insects. So a world without insects is a world without biological diversity. And E.O. Wilson told us decades ago that a world without biological diversity is a world without humans. And that's why this is an important message to everybody, whether you love bluebirds or hate them, whether you love any kind of life or hate it, whether you live in Beijing or the middle of Manhattan, you need the life around you or we're all going to disappear. What's happening to our insects? We're losing them. We're losing them. You've all seen this, insect apocalypse is here. New York Times has carried this story, related research, 3 times last year because it's so important. And what surprised me is how many people read that and how many people are upset about it. I thought everybody hated insects. So that's good. That's good news. Most of the data is coming from Europe. 30% of Europe's grasshoppers and katydids and crickets, the orthopterans, are at risk of extinction right now. Germany's supplied at a lot of numbers. 79% decline in insects since 1989. 46 species of moths and butterflies have already gone from Germany. Here's the big one. Invertebrate abundance, and think insects, has declined 45% globally since 1974. So E.O. Wilson also told us insects are the little things that run the world. And that's another whole talk, but believe him, he's never wrong. They run the world, and we've just lost 45% of them. Not good, not good. What's happening to things that rely on insects? In most cases, we are not counting them, but we do count what's happening to birds, because we have people who love birds. There's something called the State of the Birds Report, comes out every year. In 2016, they measured the risk factor for all the species of birds in North America, and they said 432 species of North American birds are now at risk of extinction. And that's not because there's just 5 left of each one of those. It's because their populations are declining so rapidly. That's the clue for extinction, that they're at risk. We have 1.5 billion fewer breeding birds today than we had just 40 years ago. And let me remind you that a billion is 1,000 million. That's a lot of birds that aren't here. And the problem here is shifting baseline. I know almost everybody here is younger than 40, so you don't remember a time when we had 1.5 billion more breeding birds around. So you walk outside, it's quiet, and you think that's normal. It's all you've ever known. None of us miss the passenger pigeon, even though it used to be the most numerous bird on the planet, about 4 billion of them. And if we don't miss them, we don't do anything. So we have to do something. We've got to figure out what's going on here. A lot of things are going on, but we can simplify it as best as possible. We have parks and we have preserves, and part of their mandate is to keep the life around us. That's what we always talk about. It's not working. So what's wrong with our parks and preserves? The biggest thing is that they are too small and they are too isolated from each other. When you take a large area like this and you shrink it down to a little habitat fragment, and this is an exaggeration, you're taking large populations and shrinking them down to small populations, and that's the problem. Small populations are the problem because all populations fluctuate. In good times they go up, in bad times they go down. If you're a large population, even in your down cycle, there's enough individuals so you can increase quickly again when times get better. But if you're a tiny population, often you fluctuate naturally and you hit zero. You blink out of your little habitat patch and then you're gone. And unless you recolonize that habitat patch, you picture a box turtle crossing anything, they don't make it. You're permanently gone, that's local extinction. Don't think about global extinction. Your ecosystems function because of the number of species in them. So think about the ecosystem in your yard. If it has fewer species in your yard now than was there originally, your ecosystem's not functioning as well. So if box turtles are still happy in the Great Smoky Mountains, it's not helping you here. We need functioning ecosystems everywhere, not just in a few parks and preserves. And studies all over the world are telling us that this is a global problem. We have not preserved areas that are large enough to sustain the nature that we need them to sustain. And that includes our largest national parks, unfortunately. Okay, I have learned that people have a limited ability to absorb bad news. I call it your bad news cup, and when it's filled up, that's it. You turn off. But you might have come here with your bad news cup all filled up. I don't know, but I got to get a little bit more bad news into your cup, and then we'll talk about some good news. We have to talk about invasive species. Let's just talk about invasive plants. We now have more than 3,300 species of plants that are considered invasive. And the definition of an invasive plant is non-native that's aggressively displacing native plant communities. And when they do that, it looks like this. This is one of the parks and preserves I'm talking about. This is White Clay Creek State Park. I drive by it on the way to work when I go to work, which isn't much these days. That's what it looks like maybe 2 weeks from now, when plants from Asia leaf out before plants from North America. It's a great time to look in your natural areas, and all the green you see doesn't belong there. All the green you see is a plant from someplace else, which has not been here long enough for our insects to adapt to, which means it's there, it's occupying space, but it's not supporting the food webs we need them to. Where these plants come from? They came from our gardens. It's multiflora rose and Oriental bittersweet and Japanese honeysuckle and bush honeysuckle and miscanthus and Callery pear and privet and barberry, burning bush, bush honeysuckle, you name it, they're all there. And again, we brought them in purposely for ornamental purposes. So about a third of the vegetation in White Clay Creek State Park is from Asia. What happens when we allow that to happen, or what happens when we load our yards with plants from someplace else? What happens to food webs? That's what we've been measuring in my lab for the last, 12 years or so. We have a number of papers that you can go read. These are published papers in scientific journals, but I know you're not going to read them, so. You know what, this is the age of fake news. I could be a Russian agent. I could be a politician. You would have no idea whether I'm telling you the truth or not. So I want you to do this experiment yourself. When it gets warmer, I call it my 12 by 12 experiment. That's 12 feet by 12 feet staked out. You get to determine how much life is gonna exist in that space by determining which plants are there and how many plants are there. You can keep it as long. Get on your hands and knees on Wednesday and count all the biodiversity that's in there. It won't take you long.
Yeah.
Or you could put a tree in there. Let's put a white oak in that space. That white oak fills that 12 by 12 very nicely. This is a plant I planted from an acorn, which proves two things. Oaks grow. I hear landscapers tell clients all the time, don't plant an oak, you won't live long enough to enjoy it. I'm enjoying it. That's 14 years old.
Wow.
You do not have to, your oak does not have to be 300 years old before you can enjoy it. It also was free.
Yeah.
It also is really healthy because I planted it small. When you buy a 4-inch caliber of oak and spend thousands of dollars in transplanting, you get instant gratification until it dies. You've got a 50% chance of dying. And then it sits there for years, decades, trying to rebuild the root mass that was chopped off so you could move it. And in the meantime, your acorn oak is going to pass it, I guarantee it. Okay, let's do our 12 by 12 experiment. Let's walk around just at head height and count the caterpillars that are on that tree. Let's do it on July 25th, 2014. We're going to find 410 caterpillars from 19 different species.
Nice.
Then we're going to stand back and take that picture so I can ask you how many of those caterpillars you see.
0.
How much caterpillar damage do you see?
None.
But if I knocked on your door and said, you have 410 caterpillars on your oak tree, get the spray can, call the man, save the tree. You don't have to save the tree. That's what oaks do. That's a normal interaction. That tree is healthy, and all those caterpillars are just in this area. I met a woman, Tammany Baumgarten, in New Orleans a couple of years ago, and she suggested that we all practice the 10-step program. Take 10 steps back from our trees and all of your insect problems disappear.
Right?
And I think that's really, really good advice.
That's pretty good.
This is the black cherry. We're still doing our experiment here. 12 by 12, count the caterpillars that are down low, 239 from 14 different species. Now we're going to do an experiment here. We're going to compare the caterpillars on native plants with the caterpillars on non-native ornamentals. So we have to go someplace to find non-native ornamentals, which is my neighbor's house.
Oh my God.
This is a good experiment because he moved in the same month we did, same acreage. He had different plant choices though. He really liked calorie pear. You might know it as Bradford pear.
Sure
So he
do.
planted 32 of them.
Oh my God, are you kidding
So the
me?
first thing we have to do is figure out which one we're going to count. Let's measure this one. Actually, the first thing we want to do is make sure he's not home.
Yeah.
I bet you think I'm going to tell you that there were no caterpillars on that tree. Not true. There was one. One caterpillar, one species. Then we go to his burning bush, carve out 12 by 12 section. Of course, calorie pear and burning bush are highly invasive ornamentals from Asia. 4 caterpillars from one species, 4 little leaf skeletonizers, too small to be part of a local food web. Okay, we have finished our experiment once. We've gotten a pattern. We got a whole lot more life on the native trees than on the non-native trees. But is that a real pattern? We could have gotten that pattern by chance alone. So we have to do it again. You have to do it again and again and again. That's called replication. So let's do it again the next day, July 26th. We're going to use the same species but different plants, and we get the same pattern. We get different numbers but the same pattern. 233 in the white oak, 53 in the black cherry, 2 in the burning bush, 1 on the calorie pear. And that is the pattern you will get no matter how many times you do that. The plants from Asia are not able to support the insect life that our native plants are able to support because they haven't been here long enough. And what's long enough? You're talking about tens of thousands or hundreds of thousands of years. It takes forever for insects to adapt to a new host. Rick Dark and I gave a talk in Williamsburg, Virginia, 2 springs ago, and after the talk, we drove across the Bay Bridge, up the eastern shore of Maryland, and the first building you get to after you get off the bridge is the Sunset Beach Inn and Grill, and there are all the calorie pears in full bloom, and that's why people plant them. They have a nice spring bloom, pretty good fall color. They don't live very long. You get the ice storm, down they come. The real reason is it's the cheapest tree you can buy on the market, and that's the only tree they landscape with. Okay, we kept driving right past the Sunset Beach Inn and Grill, and we got to this property, which is owned by a land conservancy. A group of people got together to buy these acres, I don't know how many it is, to preserve them so that they can be preserved. And look, it is thoroughly invaded with the offspring from the Sunset Beach Inn and Grill calorie pears. That's what a plant invasion does. That's what biological pollution is. That's what ecological castration is. This is the plant making 1 caterpillar. How's my chickadee going to breed there? How's anything else going to breed there that needs caterpillars? I can drive from New York City to Richmond, Virginia in the spring, and it is white all the way down, and nobody planted it. And if you're wondering why invasive plants are a problem, that's why. That is destroyed food webs. We might as well pave it over. Not really, but really, that, you know. So that's the horticultural ethical dilemma of our times. You know, we all talk about private property rights. Okay, but does the Sunset Beach Inn and Grill have the right to biologically pollute all the land around it? You can think about that. Land ownership is more than a privilege, it's a responsibility. Roy Dennis said that. He's a land manager in England not too long ago, and I could not agree more. Planet Earth is covered with a thin film of life. It's called the biosphere. And as far as we know, all of the life in the universe occurs right in that biosphere. Certainly all the complex life we're ever going to interact with. And we've chopped it up into private land ownership. Tom owns this, Dick owns this, Harry owns this, Mary owns this. Well, along with that ownership comes the responsibility of supporting all the life in the universe. This is a church I drove by in Mississippi. They're inside worshiping God's creations, and on the outside they're killing them all.
Yeah.
We're not thinking. It's the first time I've used this.
They're really bad with that.
The Earth, our little spaceship in the universe there has sprung a leak. We each have to decide which role we're going to play. We can try to fix it. We can bail and work on fixing the problem, or we can continue to fill the boat with water. Those are the two roles, those are your choices. And a lot of us are doing this without knowing about it, but now that we know about it, we have to make this choice because it will sink if we don't. All right, which plants should we be sure to have in our landscapes? We have developed a tool that is on the National Wildlife Federation website called Native Plant Finder. And what we've done is rank all the woody plants and herbaceous plants that occur in each county in the U.S. In terms of their ability to support these food webs, in terms of their ability to make the caterpillars that are so vital to these food webs. So what you do is you go there and you put in your zip code, and the ranked list of woodies and herbaceous will pop up for your county. This is new. We're trying, they say we've hired a web guy. It needs some work. My lab's role was to give them the data. Their role is to create it. So we're trying. If you find a mistake, let me know. It's not bad for most of the states, but it has allowed us to see a really important pattern here. When we look at the ranked list of all the states, it becomes pretty obvious that there are really just a few plants that are making most of the food. 5% of our local native plants are making about 75% of the food in local food webs. I'm starting to call those keystone plants. The keystone is that center stone in a Roman arch. If you take the keystone out, the whole arch falls down. If you take these plants out of a food web, the food web collapses. So without keystone plants, the species that we're trying to support in our landscapes are not going to be able to be there. They're going to have failed food webs. It won't be enough food. And this actually changes the argument. What it does is tell us it's not native versus non-native, because there are a lot of native plants that don't support a whole lot either. What we need are ecologically productive plants. So the question is not whether a plant is native or not, it's whether it's ecologically productive or not. Do we want to put ecologically productive plants in our landscapes or have ecologically unproductive plants in our landscapes? I keep getting emails. People say, ginkgos were here 7 million years ago, so they're native. I don't care if they're from the moon. If they're not ecologically productive plants, we don't want a whole bunch of them in our landscape. So what's an ecologically productive plant? How about oaks? In Kent County alone, your oaks support 454 species of caterpillars. That's a productive plant. Ginkgos support, this says 5, but they're all mistaken host records. It's really 0. Not a productive plant. Number 2 on your Kent County list are native willows, 430 species of caterpillars on native willows. Zelkova, I don't know, you use Zelkova, another plant from Asia. We're planting it because it looks like the elms we lost to Dutch elm disease. Zero caterpillars. If you're looking for a plant that will interact with nothing, Zelkova is for you. But why don't you plant a plastic Zelkova or a silk one, and then you don't have to water it, and it'll always be there. Pieris japonica. This is another important point. We have native Pieris, but it's not one of those productive genera. It only supports 2 species of caterpillars. You wouldn't make that a backbone species in your yard. I don't think Pieris japonica supports any. These are the native Pieris here. Could be a native viburnum, where in your county they support 108 species of caterpillars. English ivy.
Oh my goodness.
I mean, I could go on and on and on. These plants we load our landscapes with, and then they take over, aren't supporting the life we need. So think of the plants in your yard as if they are bird feeders. There you go, the bird feeders. Now you get to decide how well you're going to feed the birds. You can feed them a lot, or you can feed them just a little bit. This is what the landscapes around me look like. Giant lawns with very few plants in them. You also get to decide whether you're going to put food in your bird feeds. Are you going to put plants in your yard that make those caterpillars like this, or are you going to keep your bird feeders empty? There's the ginkgo back there. It's a big tree, but it's not making any food. And when we landscape without thinking about these keystone genera in our landscapes, we're not fooling the birds. Here's a little bit of data from my recent PhD student, Desiree Narango, who's now doing a postdoc in the Forest Service at University of Massachusetts. She studied chickadees in the forest, in the suburbs of Washington, D.C. And her question was, how does chickadee breeding success relate to the plants in the landscape in which they're breeding? So this is a foraging territory of 1 pair of chickadees. The star is where the nest is. This red line represents the boundary, and in that red line they did 95% of their foraging to feed their young. And that 95% of the foraging occurred on all of these plants in here. So let's look at what they are. They're all the native trees in this landscape. Basswood, sweet gum, American elm, black cherry, 2 species of oaks. But let's also look at the plants that the chickadees were not foraging on. And they're all the trees from Asia. There's our friendly ginkgo and silk tree, Japanese maple, black poplar, crepe myrtle, saucer magnolia. And it's very easy to picture a landscape in which those are the dominant trees. And if that happens, it allows you to make this comparison, which Desiree did. She compared landscapes that none of these were entirely native, but they were dominated by native plants versus landscapes dominated by non-native plants. The ones dominated by non-native plants had 75% fewer caterpillars in them, so right away you've reduced the amount of food for the birds by 75%. They were 60% less likely to have breeding chickadees at all. So the chickadees came, they looked around, there's a nest box there, but they said, no, we're not going to use it, there's not enough food here, it's a waste of our time. If they decided to use it, they laid 1.5 fewer eggs. Those nests were 29% less likely to survive. They produced 1.2 fewer fledglings, and it delayed maturation by 1.5 days, and the chicks that left were lighter. And we know lighter chicks are not as likely to survive. So that might not seem like huge differences, but when you put that into a population growth model, this is what you have here. As a function of the non-native plants in the landscape. So here you got 100% non-native. The dotted line is replacement rate. That's the number of chicks the population has to make to replace the adults that die every year. So if you're producing that many chicks, that's a sustainable population. It will neither grow nor shrink. So anything below this dotted line here is an unsustainable population. It's shrinking as you increase the number of non-natives. And anything above the line is a growing population. So you can see the only place it met the line or was above it was around 30% non-native plants in the landscape. So in other words, you needed 70% native plants to have just a sustainable population of chickadees. So this is important for 2 reasons. It's the first time it's been measured for any bird species anywhere. It ties birds directly to the plants you put in your landscape. So a lot of people say, my crepe myrtle's not doing anything. You're right, it's not doing anything, and it's not allowing the birds to reproduce. But it also gives us some wiggle room here. If you absolutely have to have your crepe myrtle, but you balance that with a couple of oaks and willows and make a lot of food, your chickadees can reproduce. She also looked at the migrating birds that stopped and rested during their migration in these landscapes. You know, migrants don't fly around our cities. They go right through them the way they always did. They fly all night long. If they have a tailwind, they can fly 300 miles in a single night. And when they come down during the day, they need to rest, but they need to feed. They need to gas up. They need to add 35 to 50% of their body weight by eating insects. 51 species came down in her plots. And if they come down in the land of ginkgo, that's it. There's nothing to eat. And that can be the end of their migration. So a lot of people say, I don't have a landscape big enough to support breeding birds. And that may be true. But if you have a landscape big enough to support one tree, and you make that a good tree, you can support migrating birds. They need your food all the way up to their breeding grounds. So you don't have to save biodiversity for a living, but please consider saving it where you live. And I know you people are on board because you already care about at least one species, the bluebird. But there's a lot of other species out there. You know, we move plants and animals all over the world, creating what ecologists now call novel ecosystems. That term was coined by Richard Hobbs here. And some ecologists are very excited about studying novel ecosystems and say, well, this is a great chance for evolution to happen, and we can watch it. A novel ecosystem is simply one in which the players, the members of that ecosystem, are just meeting each other for the first time in evolutionary history. All their interactions are considered novel.